Hello everyone, thanks for taking the time to have a look at this video. My name is Warwick Malloy. This presentation discusses the use of game engines to produce richer user interfaces using C# and .NET. As a demonstration of this concept, this presentation was made into a Unity 3D project and compiled for Android. With the use of Google Chromecast and my Nexus 5, this can be presented wirelessly without a laptop. This presentation was given at the alt.net meetup.com group in Melbourne, Australia on Tuesday the 25th of August 2015 in front of about 60 plus members. For quality recording, this is being captured on my PC, however, and you'll see that there are touchscreen controls still on the screen. And here we have Ethan, who is a Unity standard asset. So let's move on. Now we've just seen a few interesting things that I'll highlight later on. Basically engaging an audience with movement and controlling focus by changing cameras. So what we can see here is the main presentation interface, and we have controls on the left and the slides on the right. So let me introduce myself. I spend my professional hours working at MyWave. MyWave is about putting the customer in control of their shopping and service vendor relationships, and does it through a digital personal assistant called Frank. And you can see Frank's face on the MyWave logo there. Now last year in 2014 I formed a games and game tools company called Local Digital, and that's where I produced a lot of the ideas for this. I also teach Masters of Tangible Interaction Design students at Monash University in Caulfield how to use Unity to make richer human-machine interfaces. Their projects are quite interesting, and they involve touch, RFID tags, virtual reality, robotics, and all of these technologies, or one of these technologies, is used to bridge the physical and virtual worlds. Okay, so let's define richer. I wish to note that it sounds a little judgmental, the term richer, but the point is that some applications don't need to be any richer than they already are. For instance, Microsoft Word, or a calendar or email application, they work just fine exactly as they are. However, what could be richer are applications that use experience to better assist the user. One idea is a trip planner, which could show you routes and highlight points of interest along the way, or landmarks that could help the user navigate through the journey. So in what I'm calling normal user interfaces, they are for applications as we experience them today. They are typically defined by the platform they run on. They use widgets provided by that platform, and they essentially embody a sequence or process, and that's fine. Interfaces that could be richer, that might benefit, as I said, say in a trip planner tool. They could be on mobile devices using, or a tablet, and they could be using touch. They could be using movement, as in the accelerometer. They could be using GPS, and they could be using gestures. Lighting and animation can help provide focus. And you can use haptic feedback as well to provide feedback to the user. And some of these richer environments give you opportunities to train or guide the user with subtle clues, such as lighting and so forth. And that helps you make a more intuitive interface without needing a manual. So let's talk about some of the complications. 3D in a transition to a 3D development, there are a number of concepts that need to be learned. And normal user interface development doesn't teach you this or expose you to this. Many of these ideas are very mathematical. For instance, matrices and vectors, coordinate axes, Euler angles. But some of these are also coming from computer science, particularly in the computer graphics area, such as a view frustum, scene graph, shaders, textures, meshes, vertices, and so forth. So if you see an interest in developing 3D and using 3D for richer interfaces, give yourself some time to learn and ramp up. Now, why use a game engine? Game engines do this all the time. That is, they work on a number of platforms. They deliver exceptional 3D interfaces, well, the ones that target 3D. They're getting better at cross-platform, and they're getting better at being reusable. So there's a number of engines now that are intended to be used by different development companies and studios and so forth. So these are starting to get more accessible as well. So for instance, the Unity 3D engine can be downloaded for free. It has been around for 10 years in the marketplace, so it's getting quite mature, and it provides a great deal of wonderful features. You can develop your code in C#, which is a very standard development language. There are alternatives, particularly in .NET. There's also the Unreal Engine and a few other professional engines out there. Some of them still require C++, but that may be changing. The other thing about Unity in particular is that there's good documentation, very active community, forums you can go to online, YouTube videos, lots of online training also provided by Unity themselves. Also, in considering why a game engine, let's think a little more broadly. First, let's think back to the impact iPad had, or tablets in general, had on the market when they were introduced, what is it, about 5 years ago. How many PCs were put aside for applications such as just email and simple communication of those kinds? Now all that is done on iPad. Watching YouTube videos and basic consumption of the internet is now done on a couch or as you're walking down the street using a phone or an iPad and so forth. So that was a pretty big shift, and that's had such a dramatic change to the computing marketplace that PC vendors are now struggling to rethink and reposition their place in that market. It's also worth highlighting that when we think back to what was science fiction, for instance in 2007, Iron Man's interface with the computer Jarvis, where you see in the movie that has a projection, a holographic projection into space. He's manipulating with gestures, and he's designing the Iron Man suit using this computing interface. And that was completely science fiction about 8 years ago. Today, Microsoft has introduced in a number of announcements and on YouTube videos and so forth, the HoloLens product, which gives a virtual holographic computer interface involving hand gestures, and it's a completely head-mounted computer. And that's just one example. It's also worth noting that other 3D related technologies, such as virtual reality with the Occulus Rift, or even as a cheaper alternative, getting a $20 Google Cardboard and putting your mobile phone in it and using that as a VR headset. Another thing worth noting is augmented reality, and there are libraries and tools around for that. You can actually do augmented reality through Qualcomm libraries for Unity. So the next 10 years is certainly going to involve more immersive computing experiences. And I think that's getting to the point. The point is that there's a shift in the marketplace. At some point, it's going to be less about user interfaces and we will transition to computing experiences. At a high level, the Unity engine is an interesting architecture. The fundamental engine is actually written in C++ and has been ported to a number of environments. It actually runs on about 21 different platforms, and it wouldn't surprise me if that number keeps growing. For the latest information on that, see unity3d.com. But they basically build the fundamental engine for all the different environments such as Xbox One, Xbox 360, PS3, PS4, obviously PC, and PC includes Windows, Macintosh and Linux, but then also iOS, Android and so forth. Conceptually, it is an object-oriented environment. There's an object, which is a very base class of something in the engine, but everything that we would normally manipulate as developers exists as a game object. The game object has a native component to it, which is behind the scenes, and then there's the manifestation in the editor, which we can then build components for in C#, or you can also do it in JavaScript that's targeting the .NET platform. These components, as you'll see in the third line down, these components are also objects, but they are behaviors, and specifically mono behaviors. So the .NET environment uses the mono cross-platform open source .NET implementation to compile to .NET, but also to execute on the C++ native framework. And there are a number of classes that make up the engine API. These are documented, but these classes give you access to input, which includes touch or keyboard, mouse and so forth. You get access to the application, which lets you change scenes and control timing. Transform to move your objects around, audio sources, cameras and so forth. There's plenty of very powerful classes in that API. The Unity editor has a number of windows, and when you first open Unity it can be a little overwhelming. I certainly felt that way myself a few years back. The editor, the first window that's worth looking at in the editor is called the project window. It gives a file oriented view, and basically you can set up folders and any assets. Now by assets we're talking about images, 3D models, sounds and so forth. These files can be dragged straight into the project window, either into a folder or to the base and this would appear in an assets folder inside the project as it exists on your file system. And Unity will essentially import these assets, and it will also attach some metadata which it uses to manage these assets. There's a hierarchy view, and the hierarchy view defines what's on the current scene. So you can set things up in a hierarchy. Basically you can relate one object to another object, or you can put them all in the root, if you like, that is all at the same level, and they would just exist as objects in the scene. The inspector, if you click on any object in the scene view or in the hierarchy view, the inspector will show the properties of that game object and all the components on that game object. And then you can create your own components in C# or JavaScript, and you can add those to the game objects as well, and then the properties will be available for you to manipulate there as well. The scene view, as I've just touched on earlier, the scene view shows you what the scene looks like and all the objects that are in the scene. The scene view is not exactly the same as how it appears in the game, because it'll have visual handles and cues that give you ways to manipulate those objects, to move them around, rotate them and so forth. The game view, which is a separate view, that does show you what the game would look like when it's rendered in the game. And then finally there's a console, and the console is a place where error messages will pop up, and also any log messages that you wish to produce in your scripts to give you feedback about various things. That can be very useful for debugging, by the way. This is what the editor looks like. This is actually how the editor looks for the project that produced this slides application. You can basically see the scene view up the top left, and that's got the user interface there being manipulated. Down the bottom left there's the game view showing how it looks when rendered. The hierarchy is running vertically in the middle. Next to that on the right is the project view, and then to the right of that is the inspector. The inspector is showing the properties for one of the game objects, which is in fact a group of slides. And that is fundamentally the presentation overall. There's a demonstration here just as another point. So let's talk about elements of richness. One thing you can do is with 3D you can draw someone's attention to things by movement. This rotating ball here, or orbiting ball, has a spotlight which it's showing on the slide, and you can see that as it particularly goes on to the purple. And a bit like I mentioned before and highlighted, the movement of Ethan up to the door that then lets you trigger it and go inside. Again, this is showing shifting cameras to draw attention and focus to certain areas. Okay, so this application that showed the presentation slides, that's a eating your own dog food kind of presentation. And it's worth noting that Unity itself is actually doing a similar thing. So let me stop this application and let's have a look at Unity. So here's the Unity project for the presentation, and the Unity environment, the editor, actually runs on the game engine itself. And that's actually clever, and probably was even considered required by the Unity Technologies team, because it lets you preview and debug and play and control and try things with your game. But it's a very rich environment when you consider that you can, so in the scene view here, I can move around and I can obviously manipulate the objects that I'm using to make the game, and you can extend it. So for instance, again as another idea of using a game engine for a rich user interface, we have I've got a component that I've created for the editor, and if I go over here and make a new object, actually hang on, get rid of that. Let's make a cube. Let's bring it into view. There it is, a nice white cube. Now in the prefabs, yes, awesome. Now what I can do here is I can, with this cube, I can add a component. Let's add the script component I produced before called rotation path. And this demonstrates, again, using Unity as a richer user interface. So on the right, these controls here, which make up the inspector view, it looks, this is a 2D normal kind of user interface. You have some images which preview things, and you have fields that you can enter into, and that's great. But on the right here, sorry, on the left here, can't tell my left from right, over on the left we have this scene view, which lets you manipulate in 3D space. Now with this custom inspector, I've also added code that lets me define an orbit. Okay, and so with this orbit I can enter information on the right in terms of how big an orbit should be. So say roughly 4 meters with a 45-degree angle per second rotation. I can take a moon here. Oops, hang on, I should go back. Take the moon and I can drag it into this object to rotate. So the whole idea is this moon will be the thing that orbits around this cube. I can make this into an ellipse, because actually the Earth has an elliptical orbit, not that this is the Earth, but just making the point. And we can change the angle of the orbit itself. And we can do that visually and interactively, and we can see immediately the impact of doing it, which is great. I can hit play, and hitting play we can see this moon orbiting around the cube in the background, as well as having Ethan just standing there waiting for me to take him through to the slides. So let's stop that. So again, it just demonstrates not only is it powerful or enabling to go beyond the normal 2D widgets and start thinking about 3D, it can be certainly a great way to tell a story, to take the user on the journey with you visually and interactively, and that can create new opportunities for richer interactions and more engaging applications and software. They don't have to just be games. Unity has been used for interactive installations where it might actually be in a wall-mounted touchscreen with a computer in the background, and you can use a Kinect controller, like from the Xbox, with Windows APIs, and users could come along and they can gesture at it, and they could touch the screen, and they can get, it could be something that's used by a council. Such a thing has been used in Europe. There's a YouTube video that discusses interactive installations with Unity, but it's not the only one. So there are many different possibilities with these sort of environments, and with the new advances in technology such as the Microsoft HoloLens, the Oculus Rift, and even just how powerful mobile phones are becoming today, there are really new avenues, new opportunities, new things that could be done that need to be explored, and skills need to be developed now to be ready for this shift in computing. Thank you for listening.